This is very important example. If 1 omega omega square up to so on omega to the power n minus 1 are the nth roots of unity, then the product of 2 minus omega square up to so on 2 minus omega to the power n minus 1 equals to what? A, B, C or D option, right? This we need to check. Okay, we have z to the power n minus 1 equal to, yes, we all know that this is equal to z minus 1 into z minus omega into z minus omega square up to so on. It is z minus omega to the power n minus 1, right? Let's take this z minus 1 to the denominator of the left hand side. So we get z minus omega into z minus omega square up to so on z minus omega to the power n minus 1 equal to z to the power n minus 1 divided by z minus 1. Very fine. Alright. Let's put z equal to 2 because we are having here 2 minus omega square, right? So on. So if I put z equal to 2 over here, I get 2 minus omega into 2 minus omega square, so on. This is 2 minus omega to the power n minus 1. That is equal to 2 to the power n minus 1 divided by 2 minus 1, that is 1, right? So we get this to be equal to 2 to the power n minus 1. That is the first option, right? Let's also check the other options too. Okay. Here B part is NC1 plus NC2 plus NC3 up to NCn. And it is a result that the sum of these combinations is equal to 2 to the power n minus 1. This is your result, right? So these two A and B are equal, so B option is also correct. So sum of these combinations is equal to 2 to the power n minus 1. This is your result. Okay. Let's move on to the C part. For the C part, let's take this complete sum to be as, E, right? So let's take E to be equal to 2n plus 1c0 plus 2n plus 1c1 up to so on 2n plus 1cn, right? If I multiply 2 on both the sides, we get this to be as twice of E, and that is equal to twice of 2n plus 1c0 plus twice of 2n plus 1c1 plus so on. This is twice of 2n plus 1cn. Please note here, if I calculate 2n plus 1c0, this comes out to be 2n plus 1 factorial divided by 0 factorial into 2n plus 1 minus 0 factorial, that is 2n plus 1 factorial, which gives us the value as 1. And also, if we calculate 2n plus 1c, 2n plus 1, that is also coming out to be 1, right? Which means these two are equal. If I add these two, what I get? 2n plus 1c 0 plus 2n plus 1c, 2n plus 1, that is equal to 2. Yes? Okay. And this 2 can be taken as 2 into 1. This is also fine? Alright. So, I can also write 1 in place of either this or this. Right? So, can I write this as twice 2n plus 1c0? Is it correct? Right? Okay. So, what I'm going to do is, instead of twice 2n plus 1c0, I'm writing 2n plus 1c0 plus 2n plus 1c, 2n plus 1. Right? In place of this term, I'm writing the sum of these two terms. Right? Is it okay? Alright. So writing this further, for the first term, 2n plus 1c0 plus 2n plus 1c, 2n plus 1. Similarly, I can write also twice of 2n plus 1c1 as the sum of, yes, 2n plus 1c1 plus 2n plus 1c, 2n, right? Because these two terms, the values of these two terms are equal, right? So I can take their sum as twice 2n plus 1c1, right? Then plus so on. At last we get, for the last term we get 2n plus 1cn plus 2n plus 1cn plus 1. Right? Okay. Please note here, I am writing one result that 2n plus 1c0 plus 2n plus 1c1 plus 2n plus 1c2 so on 2n plus 1cn. If I take the square root of this sum, that is equal to 2 the power n, which means if I square both the sides, I get this sum to be equal to 2 the power 2n, right? Okay, so I'm going to use this result over here in the next step. On the left hand side, we are having twice of e, right? On the right hand side, I'm having the sum, that is 2n plus 1c0 plus 2n plus 1c1 up to 2n plus 1cn, which means these terms, this one, up to this, right? So writing the sum of all these terms to be as 2 the power 2n plus the sum of the remaining terms, because these two terms are equal and similarly other terms are also equal to each other, so the sum of the remaining terms is also equal to 2 the power 2n. So that is equal to, if I take 2 the power 2n common, I get this to be as 1 plus 1. That is equal to 2 the power 2n into 2, which can also be written as 2 the power 2n plus 1, right? Okay, so this implies we get e to be equal to, taking this 2 to the denominator, we get 2 the power 2n plus 1 divided by 2, that is equal to 2 the power 2n. If I mark this first result as star, I'm having here 2 the power n, right? Can I write this as 2 the power n to be, because e is what? E is 2 the power 2n. If I take the square root on both the sides, what I get? I get square root of e equal to 2 the power n, right? So can I write this as, in place of 2 the power n, as square root of e? Yes, and square root of e is what? First let me write this, from star 2 minus omega into 2 minus omega square, 2 minus omega cube up to so on, 2 minus omega the power n minus 1 is equal to 2 the power n minus 1, which is equal to square root of e minus 1, because e is equal to 2 the power 2n, right? And square root of e is what? It is equal to, yes, what we have taken e to be as? 2n plus 1c0 plus 2n plus 1c1 up to 2n plus 1cn. So this is 2n plus 1c0 plus 2n plus 1c1 up to 2n plus 1cn, the power 1 by 2 minus 1. So C part is also correct, right? So all these A, B, C, all these are correct. Thank you.